Alright, boys and girls, welcome back to the drive-thru. Here is a special video answer to a discussion question from our discussion board in calculus. Here, Gabby asks, how does geometry relate to calculus? What a great question, Gabby. You're always full of great questions. Appreciate you so much. Well, in geometry, we were able to find the area of any polygon. So like even if I had like a funky polygon using triangles and law of sines and some angles, I could find the measure of all 5 of those, and I could find the exact or very close to the exact if I had the angles exact, I could find the exact area of that original shape. I could also find the area of circles. But what if I wanted to find the area of something that looked like this? Or that? Well, I could find the area of those things with calculus, with infinitesimal calculus, by splitting these up into infinitesimally small regions that we can calculate using the limit process. See that, Danielle? But that probably doesn't mean anything to you. Who cares, honestly, what the area of this is? I mean, really, why would you ever need to find that out? Well, here, it's not really about area, that's my point, but it is about geometry. Area is essentially adding a bunch of products together. So if you think about how we found the area of this thing, we did like 1/2 base times height, and we added that to 1/2 base times height, and 1/2 base times height, and 1/2 base times height, and we added all those products together to get the area of that shape. Well, products don't just have to give you area. What if we had a snowstorm that lasted 12 hours? Okay? And during that time, the strength of the snowfall changed. You know, it doesn't snow the exact same amount every minute during that storm. So maybe it started out snowing pretty light, and maybe this is 2 inches an hour is a lot of snow. And then it snowed really heavy, and then it trickled off. Well, would we ever want to find the area under that curve? Because I can tell you, the only way to find the area of that shape is calculus. And we just stated before, why would we ever care about the area of that shape? Well, let's examine what the area of that shape is. It's all of the sums of our snowstorm, the time of the snowstorm, times the strength of our snowstorm. And you still might be thinking, who cares about that? We're adding up all of these things. If I divided all of these up into this case, like let's say we divided them up into little trapezoids. And in order to find the area of this shape, we call it like that a trapezoid, that's 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 a trapezoid, 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 okay? That would be a nice approximation of the area. What would the area represent? Let's look at it by looking at multiplying our units. Time is measured, holy cow, Twilight Zone, double rainbow. Time is measured in hours, and strength is measured in inches per hour. And what happens when we... Oh, it's going to give us inches. The area underneath that curve is the total snowfall. 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 So now you can apply that to anything that multiplies two things together, that adds a bunch of products. So what else might interest you? Well, maybe this is here, like salary for you, and maybe this is your age, and maybe we only care about this from age 22 to age 65. So maybe this is how long you're going to have to work. Okay? 43 years. What a bummer, but that's about what it's going to be. Well, let's say you start your salary at like $40,000, and up here, let's say it's $300,000. And during your life, your age changes, and your salary changes, and maybe you get a new job and you lose, but then you do better, and then at this time you retire. Or even, this is really what the calculus looks like. Dang it. Maybe you start at 40, you get a new job, you make more money, and then here you just retire. It just ends like that. Well, what would the area under that curve be? It would be, well, that's years. That's how we measure your age, times wages per year. What do you get? Oh, the area underneath this curve, it represents all the money you've ever made in your entire life from 22 to 65. Now, that might be important to you someday. So this is kind of what we use geometry and calculus for, Gabby. Thanks for the great question. Boom!